For this problem, we're given a force that's already in Cartesian vector form, and we know one point on the line of action of this force, which is point B, because the force passes through point B. We know the coordinates of this point. We need to determine the magnitude of the moment caused by this force about the AC axis. So to determine the moment caused by a force about a specified axis, we need three things. We need three vectors actually. First, we need the force vector. In this case, that's already given. And then we need a unit vector that points the direction of the axis. In this case, it is the AC axis. Therefore, we need the unit vector along the AC direction. And lastly, we need a position vector. This position vector is like a bridge. It connects the force vector and the unit vector, and it can be drawn in any way as long as it starts anywhere along the AC axis and it ends anywhere along the line of action of the force vector. So you can draw it this way, or you can draw it this way, etc., etc. And because we can draw it however we want, obviously we want to pick a convenience position vector. So in this case, either vector AB or vector CB are reasonable options. So we're going to pick position vector AB. So force vector is already given. Now we need to determine the unit vector AC and the position vector AB. So position vector AB is determined by taking the differences between the coordinates of endpoint, point B, and initial point, point A. Therefore, that is going to be negative 21I plus 24K in the unit of centimeter. For unit vector AC, so we start with position vector AC, and unit vector AC equals to position vector AC divided by its magnitude. Therefore, position vector AC is coordinates of point C minus the coordinates of point A, so that's negative 21I plus 30J divided by square root of negative 21 squared plus 30 squared. And that equals to negative 0.5735I plus 0.8192J. So now we have determined all three of the vectors. We can set up our equation. The moment scalar, actually, the magnitude of the moment of the force about this specified AC axis equals to unit vector AC dot, within the parentheses, position vector AB cross force vector. You can calculate this part first. This part alone is actually a moment vector of the force about point A. That's actually what it is. So you can calculate that first and then determine the dot product. Or you can directly set up a 3x3 matrix. For the first row, we fill in the three components of the unit vector. So negative 0.5735, 0.8192, and 0. As you can see, those are the coordinates of the unit vector. For the second row, the three components of the position vector are AB, this one. Therefore, that is negative 21, 0, 24. And lastly, for the last row, we fill in the three components of the force vector. So this one right here. So that will be 300, 400, and then negative 120. And when we do the calculation, we're again using the determinant of the component matrices, just like how we determine the cross product of R and F before. So when we calculate it, this is negative 0.5735, this first term right here, multiplied by this term, multiplied this term, minus this term, multiplied by this term. So 0 multiplied by negative 120 minus 24 times 400. That's the first term. And then we switch sign. So for the second term, it's negative minus this term, 0.8192 times this term multiplied by this term, so negative 21 multiplied by negative 120 minus this term times this term, 24 times 300. And lastly, even though we don't have to do anything because this is a 0, but if it's not a 0, we switch back to plus sign, and then we will do 0 times negative 21 times 400 minus this term times this term, 0 times 300. And of course, for this particular problem, this last term is simply 0. So after we do the calculation, this equals to 9,339 in the unit of Newton centimeter. And if we want to convert that into Newton meter, that equals to 93.4 Newton meter. And that is the answer to this problem. Now keep in mind that when you do this, because this is a dot product of two vectors, therefore the answer is a scalar. However, if you want to determine the moment vector along the AC direction, all you need to do is to take this magnitude you just determined and then attach the unit vector UAC to it.